Hello, I'm Dr. Antonio from Fluxim. With this tutorial today, I'm going to show you a new feature we developed for the Litos Lite sample holder. This is active temperature control, meaning we developed a cooling technology to control the temperature between 25 and 85 degrees. With the previous versions, it was possible exclusively to heat up samples up to 85 degrees, but not to keep it cooled also under illumination. The software is already open. It's everything set up. Let's jump straight to a measurement. In this very specific case, I want to perform JVs at increasing temperature. For this reason, I will use the sweep function that I showed in a previous tutorial. So let's just rename our recipe. Let's call it temperature dependent JV. And then we set up a sweep function. And inside of it, we want the temperature to be controlled. So we set up the temperature. Temperature will be our variable, and we will vary it between 25 and 85 with a step of 15 degrees. And once the temperature is set, we want to perform a JV. In this case, I got a few samples. They already selected. It would just be a forward JV for the sake of example of this tutorial. This is enough. Let's not forget about the temperature, about the illumination. Pardon me. Let's set the illumination here. Illumination at 100%. And once everything is over, I want everything to stop. If we want to be more precise with the temperature, we want to ensure that the sample reaches the temperature, also essentially the top surface. So essentially the temperature distribution distributes throughout the sample, throughout the substrate. Then maybe we would add a wait button, sorry, wait step, and this would last maybe 3 or 5 minutes. Longer if you want to really make sure that the temperature is distributed within the substrate. But for the sake of this tutorial, we would just skip this step. So everything is set. We can start already. We'll see if here's the temperature. We'll quickly move from 28 degrees. Today is a warm day, down to 25. Here you see a couple of plateaus because this is how the PID algorithm is controlling temperature carefully. And then the JV starts. You see the light is on. In fact, it starts with a negative current. This would be essentially STC conditions. First JV is done, and now we move into a new set temperature of 40 degrees. Temperature quickly moving from 25 to 40 degrees. In this case, the increase is quite rapid. It plateaus and then slowly approaches the set temperature. Now 55. You can follow the temperature also from the home interface. You can see from this temperature controller window, set point is 55 degrees. The temperature is increasing quite rapidly. So you can see if we keep these short steps of 15 degrees, it doesn't take more than a minute or about a minute. Now, while the temperature is increasing, I made sure the light is off. This is why I implemented the stop button so that I'm not biasing my samples. Now the last step at 85 degrees. In the case of reaching higher temperatures, it would take a little bit longer, as you can see, less than 5 minutes in any case. But consider this is a cooling block that can cool up to 20 samples at once in this case. So it's not just the area of a single sample. Then we reach the temperature. This is loss JV. Consider how long it took. I would expect the samples to be at the right temperature already. So in this case, we wouldn't need the wait button, for instance, the wait step, for instance. And then we have our measurements, and we can see that at the increasing temperature, let's just select one of the samples, for instance. At the increasing temperature, we got more and more current and less VOC, as you would expect. So this is the very first measurement. There's the lowest current and the highest VOC, and it increases. We can even just show the first and the last measurement. You see there's clearly difference as it would be expected with an increase in temperature. Now this is just the temperature GV measurement. With increasing temperature, it can go also the other way. It can be cycling between 25 and 85 degrees, for instance. This temperature is stable also for long-term measurements. We already tested it for 100 hours, more than 100 hours measurement. Let's cut here. So this active cooling can be used also for stressing. So for instance, for MPP tracking, you can keep it at 25 degrees. It will remain stable. This is it. This is a temperature control with a Litos Lite sample holder, and I hope you will have fun with it.